Welcome to the November 19th OpenZFS production user call. We have Jan, Daniel, Rob, Dan, and myself, Michael, so far. And congratulations, OpenZFS releases 2.3.5 and 2.2.9 are out. Rob, as a developer, do you have any highlights you want to share with us about those two event releases?
Nah, they're pretty modest, just point releases on stable series. There are some nothing critical but important bug fixes uh, for various niche things. There's some stuff in the BRT. I think there's like some scrub ordering things. There's some rare cases where you can hit lock things. So they're just like good, steady point upgrades. Oh, and I suppose support for Linux 6.17
Hmm.
and and also FreeBSD 15, um, back to 2.2 if those are the things you like. But yeah, just good steady as she goes kind of thing. That will probably I expect that will be the last 2.2 stable release unless something critical comes up because when 2.4 comes out, then 2.3 becomes the long term,
Sure.
and 2.2 disappears quite quietly, and we thank it. But that's it.
Cool. That said, Jan, do you know if Colin has pulled either into FreeBSD at this remarkably late date on the list of candidates for 15?
As far as I know, the goal is to release with the latest OpenZFS.
Cool.
So apparently that gets in at the last second or whatever. Good question.
There was also a 2.4.0 RC4 the other day, like 2 days ago, and I did see some activity on FreeBSD Fabricator shortly after. I get sent emails when commits with my name land, even though they're sourced from somewhere else. So
Hmm.
that's how I usually know that stuff's been imported. So if the intent is to ship that with 2.4, then I'm guessing that's
So
whatever
as far as I
15 beta
know,
currently is, should have an RC4 there.
the plan is to release FreeBSD 15.0 with OpenZFS 2.4
Aha.
release. If it And I don't know if this is a blocker and they will delay the release if OpenZFS is not done on time, or if we will have one with a released candidate as default ZFS again. I hope not.
Cool.
Let me just check what it says if I run ZFS version on the system I just updated to RC2.
Oh, 2.4 RC3. Thank you very much. Thank you for pointing that out. So
Yep.
yeah, Colin's been tracking it. Hmm.
So we are on 2.4.0 RC3 exactly.
Which was what, yesterday's release of RC2? Cool. Well, hopefully those come together nicely. Rob, do you have any comments on 2.4 from
Um,
excitement
it's
perspective?
it's looking pretty good. Like the feature set has not changed since the first release candidate, so um, we're just ironing out bugs and build issues and bits and pieces now. But like the change list gets smaller and smaller
I
and smaller. So yeah, it's going to be. I expect a perfectly sensible point oh release
Hmm.
in both
That's
the
a
good
good
and
one.
bad meanings of that.
Right, right, right.
um, there's one topic I worry about, and that is ZFS block cloning being enabled by default. Because if you ever have a system with lots of cloned blocks and you replicate it to a big backup server and you try to restore, you may be in for a nasty surprise because all your deduplicated cloned blocks are now duplicated. Because as far as I know, there's no way to this day to preserve block cloning with replication. And there's also no good tool to punch it back in. So there's no
So
tool.
from ZFS perspective, that has been enabled by default since
I
2.3.
know.
So I real so uh and it's been considered stable for
Oh,
a
the
pretty
feature
long
itself
time.
works great.
Yeah, and all this is
Uh,
well documented and all the rest of it. So like if FreeBSD are changing policy, that's kind of a FreeBSD to call to make. But like these things are well understood. So I don't know.
Well, the thing is,
yeah.
the savings is lost in send, and a user might not realize that a restore might not have those savings benefits and hopefully planned
So
accordingly.
yeah, the nasty surprise I expect people will run into is that they have something with lots of deduplication savings, and in the worst case, we will find that they cannot restore the backup onto the same hardware because they run out of space when they try to restore.
Well, in the modern era, you can somewhat over provision everything in various clever ways, and it might burn you in many clever ways.
Yeah. I
Yeah,
agree
depending on
someone
what you
will
do.
probably run it. Yeah, I agree someone will probably run into it, but
Mhm.
for mine, the danger is the danger is minimized by, regularly testing your backups and over provisioning
Yeah,
and all the standard things that people do. And the savings on the local machine can be massive. So like I would
yeah,
still I appreciate it and it's documented, but I'd still have it on by default every day of the week. So
yeah. It's a great feature to have, but yeah, I can kind of.
Point taken. It sounds like a documentation and test your backups personal testing question.
It will always preserve correctness, as in
Yep.
it will not silently corrupt your data or anything catastrophic. It's just the foot gun, which you can
Well,
run into.
the storage industrial complex has planned for that to sell you a newer storage device. It's larger than the previous one.
No, there's no
A bet.
conspiracy. Come on, it's
Yes.
the way the feature is implemented. It's kind of underneath the replication layer, so it doesn't know that it exists.
So, okay, fine. Let's talk about then the real issue. Rob, could the savings be hypothetically preserved through replication? Was that just a hard
uh
limitation or a lack of time to implement that?
it's it is a limitation of the implement of how it's implemented at the moment. The issue is that the BRT stores effectively it's keyed on DVA, so like the uh, physical physical position of the block in the pool, like on the
Oh,
virtual
okay.
device. So that's what it's keyed on. But those don't get replicated because the receiving pool has to be free to allocate the incoming block to wherever it can. And there isn't a way for us to say, hey, hey, receiver, you will find, because replication is object based, you will find duplicate blocks in these these objects because we can't go from DVA back to object without doing a full pull scan, and we don't know what the receiver has, so we can't actually say just because I have 5 clones of this block doesn't mean you have 4.
Right.
Um, so the other 4 to make that useful. So yeah, as the currently it's limited by the architecture. I think for it to happen meaningfully without a scan, it's going to need possibly some kind of active replication where the two sides can discuss their relative views of the world. Um, but it may also require like a DVA to object kind of back mapping, which we were talking about at the Dev Summit for things like the uh, uh, disk help. I need you to rewrite this block uh, 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 thing that the chap, I think it was from Seagate, was talking about. So it might be a thing we can build in the future, but it doesn't fit into the architecture as currently constructed. So
So much for
like
that.
don't expect that to change anytime soon, I would say. If I think of a great idea at any point, um, I'll give it a go. And if someone thinks of a great idea, but doesn't know where to start, they should talk to me because
Oh,
that
Amen.
would be a
I'm
good one to solve.
I'm harping about this feature because I prototyped using it for jail fin provisioning in a way you could rebase, so that you just dedupe the fake provision jails with block cloning, which works great. You can do it in a few seconds. So with a shell prototype, you could do it in probably about a second in a C code, which just has a repository of content addressed hash files and just knows that, hey, if I have a file here, I copy it in and then I hash it and see if it's in the repository of known files. If not, I add it to it.
Cool.
But this stuff does not work if the file system has multiple writers, because right now with copy file range, you can't do it safely if there's someone else who could write to the file system. And the other thing is that on replication, all the savings will be lost.
As documented. Hopefully.
Yeah,
So
but
maybe
that would
blog
be
about that, about the known risk, because it need not be a deal breaker. But yes, points taken, points taken. Was DVA disk virtual address or something else, Rob?
Yes, that
Cool.
that is it's the address of the data stored in the block pointer. The DVA is stored in the block pointer. But it's the virtual address, which is like,
Sure. Or so
so it's a
data
VDEV
virtual
pair
one.
of
address.
VDEV ID and offset,
Yeah,
or
sort of offset in size, but the VDEV is free to interpret it how it wishes. Yeah.
Got it. Thank you. So data virtual address, not disk or something.
I think, or it might be device. I actually forget what the D
Okay,
is.
no worries.
Uh,
No,
it'll be in a comment somewhere.
yep, no worry. Okay, so that said, at the risk of losing Rob and Daniel, it seems there was an encrypted raw send bug fixed a few months ago. Do we know anything about that? Like,
That came up recently when I was on a thread, some social media thing years ago. Someone was considering ZFS encryption, native encryption, and they discounted it because of some bug that they pointed out where on a send receive and you created something encrypted, something. I can't remember it, but I'd be able to find it.
okay.
Anyway, that's the encryption bug that the in inverted commas, which has been on the books for, well, since encryption was introduced.
Yeah.
So what, around
It
2.0.
seemed old. Yeah. Okay.
Yeah, and it was fixed and the fixed backported and released to like everyone. So yeah, like what was it, 6 months ago or something. But that we believe that was the encryption bug that we could never reproduce.
Okay.
And it was
I'm gonna go look for the bug report because it was mentioned in
yeah.
this.
Sorry, I'm not
Okay,
at my desk right now,
no worries.
but yeah, I can
No, but
it,
if I find it,
it's
you'll know whether or not it's the one we're talking
Okay,
about.
thanks for that. But do you want to
yeah,
jump into your
the
testing with file-based devices thing first?
Yep.
Okay,
Um,
picking up from last week.
yes,
Okay,
I
let's just
pasted a
dive into that
gist.
before we get into
So
more weeds.
the
Yes.
goal of what I'm doing here is I have a 500 gig Z root, and I want to go to a 128 gig Z root as painlessly as possible. So I found this simple test that I could do where what I'm doing here is I'm creating disk-based devices, and some are 1 gig, some are 1 gig, some are 500 meg. And then what I do, scroll down a little bit further,
Mhm.
please. So what I do is I create a Z pool with the two devices. It's just a simple mirror which reflects just what the Z root is. The status looks fine. This looks entirely normal. And then what I do is I add another, I create, oh yeah, this is a duplicate. I guess that's where I'm creating. Yeah, it's out of order, but then on line 62, I add another mirror to this VDEV, to this Z pool. So basically now it's striping, right? It must be
Yeah.
striping over these two
Yes.
pools. So now what I do is I prove I've got data in it. I then remove the first Z pool, the first mirror from the device.
Mm.
So yeah, that's the nasty way you
987.
can kind of shrink pools
Yep.
as long as they don't have any parity rate VDEVs.
And then if you look down, the Z pool has shrunk from a 1 gig Z pool to a 500 meg Z pool,
Yes,
and it just works.
yes. The downside is you now have a remapping table, which is kind of like a lighter weight dedup table you have to keep, which basically maps from the deleted mirror to the remaining mirror.
Yep.
As blocks get rewritten, this table shrinks, and I think there's always a remnant so that like device removal flag never gets removed, if I remember correctly. But the table can shrink to effectively nothing, especially for such a small pool.
Yep.
It's not going to hurt you
Yep.
unless you're on a terribly memory constrained system.
No.
Are the remappings only for existing data, or it'll be remapping for eternity?
It's for existing data. If you had run zpool status after removing that, you would have seen an I think it's called indirect zero
Yeah.
VDEV in that slot. Which is just take the DVA and rewrite it to the other DVA on wherever it moved the block. And yeah, but it will never allocate to that. So once those churn out and that table becomes empty, it can fully remove the
Yeah,
VDEV.
384 memory used for removed device mappings
Oh,
is
do you
what
have,
I
There you go.
see
could
on
you
here.
paste that
384
syntax
memory.
to the chat if it's within reach?
Pardon me?
Can you drop that syntax in the chat?
Uh,
Just
uh,
It's
so
just
people,
vSpoof status dash V, right?
No, not even dash V.
not even dash V.
Coming into the chat.
Thank you.
Finding chat.
And I've certainly seen
Now,
device removal for, oops, I didn't mean to add that, but using it more strategically is lovely.
the reason I want to use this approach is because it's so simple and straightforward. The alternatives I've seen involve creating a snapshot, having both Z pools mounted at the same time, and then having to rename them, etc. And that just seems like an awful lot of work.
Cool.
These days, I would guess also that you could probably, after removing the device, you could probably do a ZFS rewrite. And okay, it's over all the individual files, so it's a little bit janky. Okay, we might need a little bit more to help you identify which ones are actually affected. But yeah, you could rewrite it, all your data, and have it reflow it back across the.
When I do man ZFS rewrite, I'm not getting anything, but I'm on
tell us
14.
more.
Yeah, that's a 234, and then the full fat version is 240. So fair enough. But
Oh yeah.
but that is a thing that does
Yep.
what you imagine would happen if you copied a file to itself.
Yep.
As in it writes it all back down, except it does it with all the proper locking and everything. And the 2.4 version will do it without invalidating your snapshots. But yes, that's a thing you can plausibly use.
Will this be in
to
FreeBSD?
So I don't have to
Um,
delete my snapshots after I rewrote in place.
Not the 2.4 version, you don't. If you have
So if I just
the physical rewrite feature enabled on your pool, we stash something in the block pointer to say, actually, this is just a different version of a previous one. So if you've already got it in your snapshot, just treat it as the same thing.
oh, and it depends on a strong checksum, right?
Say again?
And for efficiency reasons, it depends on a strong checksum, right?
No,
Uh,
no, it's about placement. It's a whole complicated thing, but it works fine. It doesn't depend on the checksum to match the blocks because it already knows that they are the same because the snapshot is immutable, so it knows what they are by object and
Okay.
block ID within it. And so it's just a way to actually say, hey, this block hasn't changed. Even though it's different, it hasn't changed because it's got this flag on it that says this is a rewritten block. It's a different version of that old one.
Is the feature name physical rewrite?
I think so, off the top of my head.
I'll show you on the display here. Paste it there for formatting preservation.
Right.
And
We are slightly off topic of what Dan's talking about. I'm just saying that is a tool that could be put to some use to help like drain out that indirect VDEV earlier. It's a little bit blunt for that because there's no way to just say rewrite this if it has a block in it that is on this indirect VDEV. But that's a thing we could probably add.
I've
Um,
heard it's also useful for when you change compression algorithms.
Yes, it will use the new settings of
Yep.
the data set. So
That is so cool.
compression's the main one. Anything that doesn't change the logical block size. So if you change record size, it won't touch it. But if you
because it's doing it all in place, right?
effectively, yeah.
Yeah.
It's writing a new block, but it's got to fill in the hole where the old one was, so it has to be same sized.
Yeah. Rob, my next question is FreeBSD 15 doesn't have 2.4, so I guess I'm waiting for 16 possibly.
no, I just did it a second ago, a version check.
Did you?
Yeah, this is on release candidate
Ooh.
2. Yeah, no kidding. So let's just hope all those things align. Maybe you joined a few seconds later. Yeah, I know, right? So as for on topic, off topic, having nice things is always on topic.
The reason
but I will say that, sorry,
Go ahead.
I will say that upstream OpenZFS is like it's not as tightly integrated, but it is installable and usable on FreeBSD. So so that's always an option if you really wanted something.
That falls into the too much work for me.
Yeah, fair. I totally on board with that.
Yes. Thank you, Jan, for the manual page.
When we finish with this topic, I'll move on to try and find that bug report that I mentioned.
Okay, cool.
But this is the approach I wanted to take when I was moving from 2.5-inch SSDs to SATA DOMs, because I'm trying to free up drive cages and stuff like that for bigger storage. And the OS can easily fit on a 128 gig device. So that's why I'm trying to find a way of doing this that is very straightforward and simple. And it sounds like the penalty I pay for very straightforward and simple will not degrade the system noticeably. So it sounds like a great solution for what I want to do.
You can effectively in place shrink mirror pools.
Yep. And
okay.
I really like that. Rob, what were you going to say?
Oh no, I just left my mic on. I'm good.
So on that point, this specifically will not work with RAID Z, correct?
Data set, sorry, VDEV removal for RAID Z does not exist.
Got it. Thank
And
you.
neither does DRAID as far as I remember.
Yeah,
So
D
parity
rate's in the
RAID
same boat.
means you can't remove the device.
Okay, and then also, which makes some sense because it's a lot more complex. That said, does the rewrite improve fragmentation or worsen fragmentation? Thinking back to the
I
mythical
s-
block pointer rewrite, as I recall it.
Well, I suppose if anything, it's going to worsen it slightly, just because it's got to evacuate all of these individual blocks, and it doesn't know what any of them are, so it
Mhm.
can't do. So it's going to be poking around looking for holes. It can't necessarily do smart placement and bits and pieces like that because they may be unrelated, but like probably averaged out, not really significant. Most of the cost is going to be bouncing through the indirect table.
Okay, cool.
This would be useful to rebalance storage allocation across big pools with lots of VDEVs, right? So if I have a pool, let's say with 10 pairwise mirrors, and then I add 4 more, and I do a rewrite, would that rebalance the storage allocation among all mirrors?
Rob found the encryption fix and has gone silent, perhaps to order another latte.
I found the issue in question and mentioned Rob in chat.
Yes. So let's see.
It's
Maybe they both have it.
issue
Oh,
494.
there's one fit. Here's the fix. My browser will catch up with wetware. Oh, up there. Oh, be good. That one, and thank
Wow.
you for that link.
494. That's
494. Wait, what? What just happened?
Oh, that's the doc. That's the doc one. Yes, that's referring to the same bug.
It's referring to the same bug which has been fixed.
Yes, that's the doc repo. I didn't realize what you meant. But yes,
Okay.
that bug is fixed. Yeah, and we
Okay.
pushed back on we pushed back on adding documentation because although it was a thing that people talked about, it was actually very like the reason it existed for so many years is because we could never reproduce it. We'd heard about it, but yeah, we couldn't figure out how to reproduce it. And in practice, it seemed that most people were happily using encryption, raw send, and replication, and everything was fine. So, but you
Okay.
don't hear from people where everything is working fine. So,
Right.
I have corrected the person. Well, I've replied to the thread.
but
And
yes, it is believed to be well understood and fully fixed now, and we have not heard of it since. And absence of evidence and evidence of absence, so obviously is a thing. But that's as much as we know and as much as we can do.
Yes, sir.
Rob? I don't know if I missed your reply, but would ZFS rewrite rebalance the storage allocation after adding new VDEVs?
Yes.
Thank you for confirming my suspicion that it should do that.
Yeah.
well, it's been a very interesting.
And I'll say for more on a kind of again semi-related area, Paul Dignelli's talk about AnyRaid at the Dev Summit might also be interesting because this is the like mismatched drives, the drive sizes VDEV type, but which is implemented by effectively like internally partitioning a drive into like 16 gig chunks, and then we can move, it's called tiles, and then we can move those around across drives individually and do stuff. But there has been some conversations at the summit, and it looks like there might actually be some enterprise use cases for along these exact lines for the RAID Z version of that, because um,
Um,
basically,
Please
basically
go
the
ahead and
VDEV
finish.
is designed under the hood to move data around on different drives, which means you could actually you can't necessarily redo the parity, but you can, or maybe you will be able to redo the parity if we get it right, but you can move data around among disks underneath the the top VDEV. So that may be
oh,
a future development that will solve a lot of the issues around moving and resizing and reflowing RAID Zs in different ways. So it's speculative, but if you really like, it's being worked on. So
would this potentially open the way for having different rate levels inside on kind of the same disk, so that you can have, let's say, mirror for the metadata and parity rate for big enough blocks
Goodness.
using different tiles on the same disk? So you have like mirror tiles and you have parity tiles.
I feel like it's theoretically possible, but I don't know how hard the math is. Um, basically, it's all how many cases can you solve the bin packing problem for? Like, is the
Um,
entire problem. So no in the general case, but maybe there's enough places where we can make it work well. Because we have to make sure that for every write based on its redundancy policy, so like
mhm,
the copies parameter, we are able to find space
mhm.
in enough tiles across enough physical drives to service that. And then we have
Yeah,
to actually maintain and then we have to maintain the mappings of that properly. So it's a theoretical yes, but math. And I'm
yeah,
not good
okay.
at math. Paul's really good at math, so maybe.
Yes, sounds like a kind of problem which starts out trivial until the pool is like almost full, and then it's really disgusting.
Hmm.
Yeah. Everything's easier if we've got space.
Could you define tile for those of us who have heard it like once and only in person?
The yeah, basically it's just I think it's 16 gig, maybe it can go up to 32, but it's basically just a 16 gig region of a disk. It's under the hood, but what we do is really it's a layer of indirection. It's saying underneath like it has its own kind of little is it part of the meta slabs, or it has its own little like mini allocator, so it's basically like, oh, we need to write this
Uh,
Let
um
him finish,
uh, so,
please.
um yeah, a tile is just a 16 gig region that we can write data to and we can allocate data to. But what we can do is, because each tile within the entire VDEV, so across all the disks, is numbered, and we maintain a mapping table of physically where it is, we can assign a bit of data to tile number 27, which happens to be on disk 1, and then later we can move tile 27 to disk 3 by just copying it over and rewriting the mapping table. And so we have the ability to like reflow based on tiles. So like you add a new disk and we can go, oh, that disk is very empty, so why don't we move some tiles over to it? But so that's basically what a tile is in isolation. And then the whole trick with AnyRaid is just making sure that, because if you have say you have two 1 terabyte drives and a 2 terabyte drive in like an AnyRaid mirror,
mhm.
then we have to make sure that we want to write two copies of the block. So effectively, for any given bit of data, we have a copy of it in two tiles. We just want to make sure that we always select two tiles that are on two different physical disks. And if we move them later, we have to make sure we move them so we never have your two copies on the same disk, basically. And it's just there's a bunch of like math and data structures to bolt it all together. But a tile is just like a little virtual partition.
So what
So-
space would you get from a combination of a 1 terabyte and a 2 terabyte drive?
Um,
1 terabyte.
From
well,
the
a terabyte
example.
if you set it up as a mirror.
Right, you get
So
one
if you-
whole terabyte and you
so-
kind of waste space like you could currently do.
No, because right now, if you had three drives, two 1 terabyte drives and a
Oh, I see.
2
Okay.
terabyte, if you made them into a three-way mirror, you would get 1 terabyte. Oh, sorry, I
Right.
misspoke.
Well,
But if you make them into an AnyMirror 2, so an AnyRaid, it's called AnyRaid, but it's a bit weird. But then you would get an effective 2 terabytes of space.
I see.
So let's
In mirror
simplify that a
configuration,
bit. So the way I understood both you and the talk is that it's effectively like partitioning your disk into lots of 16 gigabyte partitions, and then doing a ZFS pool on top of those partitions. So if you have like two 1 terabyte drives and a single 2 terabyte drive, you could manually create a pool with by creating a 1 terabyte partition on one disk and 1 terabyte partition on the other 1 terabyte disk, and then two 1 terabyte partitions on the 2 terabyte disk. And for this trivial case, you can solve the problem in your head easily. You create this, and then you create two mirrors where you have one partition on the 2 terabyte disk in each mirror, and the one disk at the other element. But that's hard to do for more complicated things, and you can't dynamically rebalance it. By letting ZFS solve the problem of kind of coloring the tiles so that there must never be a tile which is like the mirror of another one on the same disk, so that you do not destroy the redundancy which is supposed to come from RAID. ZFS kind of solves this allocation constraint for you, and you can, at the cost of a kind of tile interaction table in memory, but you need only one entry for 16 gigabytes. So yeah, for your home lab crowd, that's very good trade-off. Because they can finally take all their barely working disks and then create a n-3 parity RAID over a dozen dying disks. And
yeah, but it's
for
also
all
useful
the-
with good disks. Like it is a much, in a lot of ways, it's a much nicer way to grow a pool over time, than RAID Z expansion. It's it sort of has more. I don't know, I guess you have a choice. I don't think it's just a dying junk drawer disk.
yeah, but
It's certainly not I put a whole shelf of disks in at a time. But as we're finding out, as we're talking to more people, it's the RAID version is kind of has good enterprise use cases, I suppose, because being able to just move out parts of a disk, or expand a pool and reflow across it and things like that all under the hood is actually like quite appealing. It's kind of what people hoped they would get with DRAID without some of the pain of wide stripes and things like that. So at least that's the conversation we're having, and it kind of surprised us. We hadn't really thought of it as an enterprise feature, but we're hearing it's like, oh yeah, we've used that. All right, okay.
Well,
let's imagine you have something like TrueNAS, and someone has a NAS at home which is has a capacity of up to 6 bays, and they start off with just 3 disks and then want to grow over time by adding individual disks. And they may be different size because they buy them over time. And then something like AnyRaid would be a perfect fit for them.
Yeah, absolutely. That's what it was originally designed for.
Yeah. And this crowd has been harping about ZFS is unusable. I have to use AnyRaid or some hacky symlink based solution like what's it called? Not AnyRaid, some other AnyRaid or something like that. No,
Yeah, AnyRaid, which is
yeah, where they
very odd.
So for what it's worth, I think I heard Matt say during the summit that perhaps they should have used tiles in the first
SnapRaid.
place. What, Raid?
SnapRaid, it's kind of a hack where it balances the file and kind of like a big Usenet transfer would then create parity files by matching up similar sized files and then optionally creates a unified symlink maze.
Goodness. Oh dear. No,
Yeah.
thank you.
Yeah, you
Like
just
you
ask for
just
trouble. But
copy
yes,
stuff
Matt
in
said
and
that, and
then
it
run
was
the command to recalculate the parity, and then you have redundancy. It's wild.
Cool. Archie, you've been quiet. Do you have anything?
No, tiles are awesome. We need to use them more, and it did sound like the fun way to do things. It works better with the more disks you throw in of different sizes, and it just kind of intelligently spreads stuff out. It is not just meant for dying disks. I do not appreciate the implications that home labs can't be just as important as production. I would kill people if they destroyed my kids' pictures. So, that's why I use the FS.
I didn't mean to say that home deployments
I'm
are
razzing you,
unimportant.
Jan. I'm razzing you.
Just that the people
Take it to the
who
razzing call.
Sorry, I am paying attention. And I don't mean to cause strife.
Well, and it sounds like you got to pay attention to Paul's talk, unlike some of us who are spinning plates. But yay, great. And Archie, thank you for your help at the summit. And it sounds like Matt said thank you today through a various
Okay.
nifty mechanism.
Okay, thank you.
Oof, cool. That sounds quite exciting for 2.4 and FreeBSD 15.0. Other thoughts, questions, ideas, comments, discoveries? I have nothing new to report on the test framework insofar as I really need to get those aforementioned videos out the door. Yep, ball's in my court. Daniel B., anything else while you are commuting? You have fancy trains and stuff. Rob, so are you working on anything nifty that you want to report to the group?
no, I'm not. I mean, I could tell you all about range locking bugs, but it's of no consequence. It's just doing my head in. I literally lay awake like 3 hours last night thinking, could you represent a range lock as like a 3 or 4 element vector in a space and then derive a natural sort order? Anyway, so I'm not sure because I was half asleep. But anyway, no, not me.
Cool.
Rob, do you happen to know if anyone is working on a kind of version like Marv mentioned of copy file range where you, instead of just overwriting the target file content, it will only dedub it if it's the same content so that you can use it to safely dedub while the file is accessible to other processes?
No, I don't know if anyone's actively working on it. There is a PR in an older PR in for the dedupe range syscall on Linux, which is exactly what you described. But that person disappeared, and that patch is on the way there. But it had some locking issues, so but no one's working on it at the moment, as far as I know.
Cool. Well, all I can say is keep up the good work. There's always more to be done. And Rob, from afar, would you like to do the honors, which I believe you know the definition of at this point, but I'll help you out if you don't.
Yeah, slam that like and subscribe button.
Thank you,
Woo!
sir.
Internet.
Yay! Influencing the influencers. Have a great one, everyone.
Bye.
Same to you.